Hello learners, and welcome to today's lesson of Geometry of 2D Shapes, Quadrilaterals, where today we are going to be focusing on the practice and application questions. Let's get right to our questions. Now, firstly, we are going to start with reminding ourselves of those quadrilaterals. So we're going to start with a question here where we are going to be required to name the following quadrilaterals. Now, how are we going to name these quadrilaterals? We are going to look at the properties, and then we are going to name the quadrilaterals looking at the properties. This first quadrilateral here, we can see that we are shown that AD is a parallel to BC. So those opposite sides are parallel. Then we have another pair of opposite sides that are parallel, which is AB and DC. And of course, parallel is shown to us by the symbol that we use for parallel. Now, as we can see there, the first property that we have here is that the opposite sides, or that two pairs of opposite sides, are parallel. What else are we shown here? We are also shown that the opposite sides are equal. So we can see there that AB is shown to us to be equal to DC, and that is the symbol that is used for equal sides. And also we have AD that is equal to BC, and that is the symbol that is used to show that these sides are equal. So now we know that two pairs of opposite sides are parallel, and we know that two pairs of of opposite sides are equal. What quadrilateral are you thinking of? If you are thinking of a parallelogram, then you are absolutely correct. So this is definitely a parallelogram. Let's move on to the next quadrilateral. Now, in this quadrilateral, we are given also shown that the opposite sides are parallel. So as we can see there, we are shown that KL is parallel to NM. But they are not the only two opposite sides that are parallel. We are also shown that KN is parallel to LN. So now we have two pairs of opposite sides that are parallel. What else are we shown in this quadrilateral? Well, we are shown that all of the sides are equal. So we do have KL, which is equals to LM, which is equals to NM, and that is equals to KN. So all of the four sides are equal. Now, for the fact that it has two pairs of opposite sides that are parallel, that makes us think of a parallelogram. But now, this is a special parallelogram. And why is that? That is because of all of the sides being equal. So all four sides are equal. So what quadrilateral are you thinking of? Of course, a special parallelogram, which is that rhombus. So we know that with a rhombus, all of the properties that apply for a parallelogram also apply for a rhombus, and we know that because it's a special parallelogram, then we can conclude that it is a rhombus. Now, before we can move on to the other quadrilaterals, looking at these two parallelograms, so we have a parallelogram and we have a rhombus, which is a special parallelogram. Do you know what properties or what we can say about their diagonals? Yes, so let's look at this first parallelogram here. So we can just write there that it is a parallelogram. And when we are thinking of the diagonal, now remember, a diagonal is a line that goes from one vertex of a polygon to another vertex. And in this case, the diagonal is DB. So that diagonal, or that is a diagonal, then we have another diagonal which goes from one vertex to another vertex, and that is diagonal AC. What do we know about those diagonals? Well, where they meet, we can just say they meet there at M Where they meet, they bisect each other. So this means that DM is equals to MB, and it also means that AM is equals to MC. Now, since as well all the properties of a parallelogram apply to a rhombus, so what does this mean for our rhombus? Well, it still means that the diagonals bisect each other. So there we have our two diagonals, which is NL and KM. Let's say they meet at A. So of course we know that this should mean that NA is equals to AL and KA is equals to AM. But because this is a special parallelogram, the diagonals, they meet at 90 degrees, which means that they are perpendicular to each other. Now, that's not only what they do, they also bisect the opposite angles. So those angles there are bisected, which means those two are going to be cut in equal parts, and those two are going to be cut in equal parts as well. That same thing applies for the other opposite angles, which is angle K and angle M. They are both bisected, right? And the last thing about a parallelogram is that the opposite angles are equal as well. So let's not forget that those opposite angles are equal. This means that angle D is equals to angle B, and this means that angle A is equals to angle C. And of course, this will also apply for a rhombus as well. Let's move on to another quadrilateral. Now, this quadrilateral, we've just been given one property, and that is that WX is parallel to ZY. So it's only one pair of sides that are parallel. What quadrilateral are you thinking of? If you are thinking of a trapezium, then you are absolutely correct. This is definitely a trapezium. And remember, we do have an isosceles trapezium, and we also have a right trapezium. With an isosceles trapezium, we'd also have the other two sides, the opposite sides that are not parallel. They would be equal. And then again, with a right trapezium, we know that it is when we have one pair of angles that are equals to 90 degrees. Let's look at the next quadrilateral. Do you recognize that quadrilateral? What are we given here? Well, we are shown that SV and ST are equal. And when we look at those two sides, they are adjacent to each other. Then we are also shown that VU is equals to TU. So what does this mean? Since as well VU and TU are also adjacent, and we have been shown that they are equal, that means here we have two pairs of adjacent sides that are equal, and that can only be a kite. That can only be a kite when we have two adjacent sides that are equal. But when you think about it, there is another quadrilateral that has two adjacent or two pairs of adjacent sides that are equal. Are you thinking of that quadrilateral? Yes, it is a rhombus. Remember, a rhombus is a special parallelogram, but it is also a special kite. Why can we say that? We can say that because the adjacent sides are equal, which is KL and LM. They are equal, and the other adjacent sides are also equal, which is KN and NM. So a rhombus also has two pairs of adjacent sides that are equal. And if you remember the diagonals of a kite, they meet at 90 degrees, which is the exact same thing for a rhombus. The diagonals of a rhombus also meet at 90 degrees. So a rhombus is a special parallelogram. It is also a special kite. Let's move on to the next question. Now, this question here, we need to look at the property that is listed below and tick the quadrilateral that this property applies to. So we have there at least one pair of opposite angles is equal. So we are looking for a quadrilateral that has at least one pair of opposite angles that are equal. So we know that the opposite angles that are equal is definitely a parallelogram. And if it applies to a parallelogram, that means it applies to a rhombus as well. What about a trapezium? Does it have opposite angles that are equal? No, it does not. And what about a kite? Does it have at least one pair of opposite angles that are equal? Yes, a kite also has at least one pair of opposite angles that are equal. Let's look at the other properties that we can identify or match with our quadrilaterals. Now we have there all four angles are equal. Now which quadrilateral has all of the four angles to be equal? Is it a rhombus? No. Is it a parallelogram? No. Is it a trapezium? No. And is it a kite? Not at all. So none of these quadrilaterals have all of the four angles that are equal. What about the sides that are equal? So all four sides that are equal. Well, we know that a rhombus definitely has all four sides to be equal. But what about a parallelogram? No, it does not. A trapezium does not have all four sides to be equal, and a kite does not have all four sides to be equal. Let's move on to the next two properties that we can identify with our quadrilaterals. Any two opposite sides are equal. So any two opposite sides are equal. Definitely a rhombus has two opposite sides that are equal. A parallelogram has two opposite sides that are equal. What about a trapezium? Does it have any two opposite sides that are equal? The answer there would be no, it does not. And then what about a kite? Does a kite have any two opposite sides that are equal? A kite does not have two sides that are equal, or any two sides that are equal. Let's talk about the next property, which is adjacent sides that are equal. Now, does a rhombus have adjacent sides that are equal? Yes, a rhombus does have its adjacent sides equal. What about a parallelogram? Does a parallelogram have adjacent sides that are equal? No, a parallelogram does not have adjacent sides that are equal. Let's think of a trapezium. Does it have adjacent sides that are equal? The answer there would be a no. A trapezium does not have adjacent sides that are equal. And then lastly, what about a kite? Does a kite have adjacent sides that are equal? Yes, we can say that it does have adjacent sides that are equal. In fact, a kite has two pairs of adjacent sides that are equal. So that is how we can describe the properties of our quadrilaterals when it comes to the sides and to the angles. But what about those diagonals? Let's see if we can identify which quadrilateral belongs to which property. Let's look at the next one here. It says two diagonals bisect each other. Now, two diagonals bisect each other. Let's think of a rhombus and the diagonals of a rhombus. Do they bisect each other? Yes, they definitely bisect each other. What about a parallelogram? Do those diagonals bisect each other? Yes, we can agree that those diagonals bisect each other. What about a trapezium? Do those diagonals bisect each other? No, they do not. And when it comes to a kite, do we have diagonals that bisect each other? Now, when you think about a kite, we know that the one diagonal that is also the axis of symmetry is the one that bisects the other diagonal. So when we have a kite like this, we know that the one diagonal that acts as the line of symmetry as well would be the one that bisects the other diagonal as well. So we don't have two pairs, we don't have two diagonals that bisect each other. We only have one diagonal that bisects another diagonal. So we could say that a kite does not fit into that property as well. What about diagonals that intersect at 90 degrees? Which of these quadrilaterals have diagonals that bisect at 90 degrees? So in other words, diagonals that are perpendicular to each other. Of course, we know that the diagonals of a rhombus intersect at 90 degrees. The ones of a parallelogram do not intersect at 90 degrees, as well as a trapezium, they do not intersect at 90 degrees. But the diagonals of a kite definitely intersect at 90 degrees. Let's look at the last property that we need to identify into those quadrilaterals. So it says there, the sum of the interior angles is 360 degrees. The sum of the interior angles is 360 degrees. Now, remember, when it comes to a quadrilateral, and this is any quadrilateral, if we were to cut this quadrilateral in to two, meaning from one vertex to another vertex, we know that it will create two triangles. And what do we know about the interior angles of a triangle? We know that they give us 180 degrees. So now, since any quadrilateral, when we take one vertex, or let's put it this way, any diagonal of a quadrilateral will split the quadrilateral into two triangles. And if each triangle is equals to 180 degrees when it comes to the interior angles of a triangle, this means that together the interior angles of a quadrilateral, and this is any quadrilateral, will be equals to that 180 plus that 180 degrees, which will give us 360 degrees. So this means that the sum of the interior angles of any quadrilaterals will be equals to 360 degrees. So yes, a rhombus adds up to 360 degrees when we add those interior angles, a parallelogram as well as a trapezium, and also as well as a kite. So we know that those properties, or we know now that we can identify each quadrilateral if we are just given the properties of that particular quadrilateral. Let's quickly go to an ad break and then we'll see you just now.